Hello everyone, my name is Nikita and I'm from the Bodhi Academy. In the last video, we were doing the chapter Work and Energy from 9th Standard Science textbook and we did till kinetic energy. Today we will be learning more concepts and today we are going to study what is potential energy. Okay. So when we were talking about kinetic energy, we said that any object which is in motion, okay, which is in motion and mainly whose velocity is changing, that is said to possess a kinetic energy. Okay, and faster moving object will have more kinetic energy and slower moving objects will have lesser kinetic energy. Today we are going to see something called as potential energy. This is also a type of mechanical energy. To understand this, we will take an example. Okay, this activity 10.8. Take a rubber band, hold it at one end and pull from the other. Okay, if you're going to hold a rubber band and okay, if you hold a rubber band, you are holding it from this side and you are pulling it on the other side. Okay, the band stretches, right? There is a stretch in the band. So release the band at one of the ends. At either of the ends, if you release the band, what will happen? It will go and hit. Okay, it will go and hit on that side, no, which you from which you had released. The band will tend to regain its original length, and it will regain its original length. Obviously, the band had acquired the energy in its stretched position. How did it acquire the energy when stretched? Okay, so what did we see when the band was stretched? Okay, when the band was stretched, it had acquired energy. Okay, it was acquiring energy and this energy was stored. Okay, and this energy which was stored was not used for changing the velocity or changing the direction of motion, nothing. It was just stored. Okay, so the energy gets stored due to the work done on the object when it was stretched. So stretching is the work done on that object. When it was stretched, the work was done on that object, and due to this the energy was stored. The energy transferred to an object is stored as potential energy. Okay, so the energy which is stored is the potential energy, which is not used to cause a change in the speed or velocity of the object. Okay, so the type of energy in which work is done to store the energy and it is not used to change the speed or velocity of the object, it is called as potential energy. Okay, so this is potential energy. So this is one definition of potential energy. Another one is potential energy of an object at a height. Okay, when an object is placed at a height, it is also said to possess a potential energy. An object increases its energy when raised at height, when raised through a height. Okay, if you place an object through this height, it experiences or it experiences an increase in its energy. This is because the work done on it is against the gravity while it is being raised. We know that there is gravitational pull from the earth. Okay, and when you are keeping an object on top, when you are raising an object on top, you are doing the work against this gravitational pull. Okay, against this gravitational force. Okay, so that's the reason it is gaining an energy. Okay, so potential energy at height. object at a height gains energy as it is raised against the gravity. Okay, so over here it is easy to arrive at an expression for the gravitational potential energy. So that's the reason it is called as gravitational potential energy of an object at a height. Now consider an object of mass m and it is raised through, okay, consider an object of mass m which is raised to a height h, and the force, okay, the gravitational force is F, okay, and we know that acceleration will be due to gravity is g. So now if I have to write the work done of an object, okay, since the object is raised at a height h of mass and it is of mass m and the force acting on it is F, okay, so now if I have to write the work done, if I have to find out the work done on the object, then work done is given by W, right? So that will be W is equals to, we know that work done formula is F into S, and force is mass into gravity, acceleration due to gravitation, and now displacement. What will be the displacement? Okay, it is displaced from the lower to the higher position by the height h. So okay, so displacement is, the distance is h. So the formula for this work done is mgh, and that is given as, work done can be written over here as the potential energy. Okay, so the potential energy is mgh. The formula for potential energy is mgh. Okay, it is useful to note that work done by gravity depends on a difference in vertical heights of the initial and final positions, and not on the not on the path along which the object is moved. Okay, it directly depends on this path and not along the path which the object moves. Okay, so the formula for potential energy is, potential energy due to height, okay, is mgh. Okay, now we will see some numericals based upon kinetic energy and the potential energy. Okay, let's see this numerical. An object of mass 15 kg is moving with a uniform velocity of 4 meter per seconds. What is the kinetic energy possessed by the object? Okay. So what you have to find is the kinetic energy. Okay, so what is given is, mass is given as 15 kg, velocity is given as 4 meter per second. You have to find the kinetic energy. Kinetic energy is equals to half mv square. Okay, so half into m is 15 and v square is 4 into 4, which is this. 15 4s are 60. 120 joules. Okay, 120 joules, right? So the SI unit of energy, kinetic energy, is joules. Now next, we will solve this for potential energy. Find the energy possessed by the object of mass 10 kg when it is raised at a height of 6 meter above the ground. Okay, so mass is 10 kg, height is given as 6 meter, and g is 9.8. So potential energy is equals to mgh, 10 9.8 into 6. So the answer is 588 joules. Okay, so this is very simple. These problems are very simple. You have to solve the problems. Okay, this is how you have to solve the problems of potential energy and kinetic energy. Now we will see the law of conservation of energy. Now what is this law of conservation of energy? The law of conservation of energy says that energy can only be converted from one form to another. It can neither be created or destroyed. Okay, the total energy before and after transformation remains the same. So this law says that one form of energy, okay, one form of energy can be converted to the next form of energy. Okay, but the total energy remains the same. Okay, if it was 10 joules over here, it will remain 10 joules over here. It will not change. The amount of energy will remain the same, only it is getting converted. Okay, so the mathematical statement of this is the total potential energy and the kinetic energy is constant. Potential energy plus sum of the potential and the kinetic energy is a constant. Okay, now for example, consider a simple example. Let an object of mass m made to fall freely from a height h. Okay, let's try to draw this. Now the object of mass m is allowed to fall from a height h. Okay, so now this is suppose the cliff. The object is placed over here. Okay, and it is allowed to fall from this height h. Okay, and the object is of mass m. Now when it is on the top, okay, when it is on the top, we know that potential energy at a height, the energy of that particular object at that particular position will be potential energy is equals to mgh, right? And what will be the kinetic energy over there? The kinetic energy will be 0. Okay, so this is first case. So in the first case, this equation will be EP plus EK is equals to constant, right? So in this case, EP is mgh plus EK is 0 and it is constant. So this will be the first situation at the height. Now when the object is falling, okay, when the object is falling, now the object is falling at this point, when it is in between, Okay, when it is in between, what will be the situation? The when it is falling, okay, EP becomes 0, and because it is moving with the velocity, what comes into picture? We have half mv square. Okay, we have velocity now, so we have kinetic energy now. This is the second situation. Okay, the second case. So in the second case, EP plus EK is equals to constant, right? So in this case, EP is 0, let EK is half mv square. Okay, so now what have you observed over here? What we have observed is that as the object is falling from the top to the bottom, the potential energy, okay, the potential energy is getting converted to kinetic energy. Okay, the potential energy is getting converted to kinetic energy, and there is no change or no loss or addition of energy, and it remains a constant. Okay, it is a constant in both the cases. So this is satisfying the law of conservation of energy. Okay, energy is cannot be converted from one form to another. It can neither be energy can be converted from one form to another. It can neither be created nor be destroyed. The total energy after transformation remains the same. Okay, after conversion, total energy remains the same. So this is talking about the law of conservation of energy. So today what did we see? We saw what is the potential energy at the height. We saw two numericals based upon the concepts, and finally we saw the law of conservation of energy. Okay, so this is it for the video. In the next video we will be dealing with the last part of this chapter. So yes, thank you for watching my video. Please like, share and subscribe to our channel.